Tim. Good to
Yeah,
see you,
yeah.
my man. How you doing? I feel like we both locked eyes. We're waiting for the other person to
Ah,
speak first. It was
I
a
wanted to.
classic hallway
Uh,
situation of you both intersect coming down and both juke right and then left simultaneously before someone just barrels through like I just did. How you doing, buddy?
yeah, I'm just fine, just fine. How are you?
Doing all right, doing all right.
Yeah.
And kind of in light of today's topic, I'm curious, have you ever worked in an ecosystem other than the Java ecosystem as a professional software developer? Have you always been a JVM guy, or were you ever a Python scripter
Uh,
or a Ruby on Rails or a .NET
I,
person?
I've dabbled in Python for a couple of projects in the past.
Hmm.
And since you added the qualifier like as a professional, then that kind of subtracts anything I've done in like C Sharp or
So you've been
JavaScript, TypeScript. So
a
that's
C# hobbyist before?
well, like, it was part of the curriculum, but that's been a long time ago. Like,
I see. Yeah.
so celebrated my 40th last week, so that means that it's 20 years ago that I think maybe
C-
did anything related. So,
Congratulations, congratulations. Yeah, it was probably a bit different then. Yeah, I when I used to work at Microsoft, I did some C, C++, and C Sharp, but that was like 10 years ago. So I'm a little rusty
hmm
on it at this point, which makes today's guest all the more exciting and interesting to talk to. But first, I
absolutely,
think we have some
absolutely.
announcements.
Yep, yep. As always, we'll take you through a couple of things new in the past week or so. After that, I'm going to take you through a couple of quick talents. And the first thing that's new is that, like last week, we had a video online of the keynote of the Code Remix Summit that we had 2 weeks ago, 2 weeks, 3 weeks ago. But now, if you want to do a quick read up of the content that we shared there in the keynote, then you can now go to this particular link, and then you can read all about the things that are shared there. So, insights from Morgan Stanley, from Dovecats. We were just really pleased that he was able to share as much as he could over there. So that's out. Also out is that we updated our regular blog where you can learn how to update to newer Spring Boot versions. This one, of course, now with a special update for the Spring Boot 3.5 release and the Spring Cloud 2025 release. So if you want to learn both what's new and how to upgrade, then go to the blog that we have associated there. And then there's a very good reason for you to want to upgrade, because if you're still on 3.3, then support for that one in the open source is going to expire at the end of this month. So you have about like 4 weeks to go until you are out of support and getting on to 3.4 and 3.5 there. So really recommend you upgrade. I know both Andrew and I, we like to live on the edge a bit of dangerous hobbies, but running on outdated versions is not one of them. So. Now, beyond that, we also did an announcement last week of everything that's new in the release that we did. So if you want to follow up on that, I think the best place to do that is on Blue Sky or whatever bird-related platform you were using previously, where you can see just all the things that were new. So some of the things new are collaborations with Azul, with FoundCheck, as well as DivBlue. And then also new is that we have yet again expanded our recipe catalog. So do keep in mind, this number is from last week. So we, at the time, had 3,779 recipes, and we'll give you a bit of an update in a couple minutes. But new are these modules and a lot of additional recipes for you to help modernize your code. I wanted to call out one in particular, which has been contributed by a community member of ours, who, while working on his thesis as well, has also been adding a lot of recipes for folks that might want to move away from DropWizard onto Spring Boot. And I remember, like, a long time ago, those frameworks each were up and coming a bit, and folks would pick one or the other. Whereas nowadays, I think it's clear that Spring Boot has a lot more momentum behind it, so you might want to jump over to across from DropWizard to Spring Boot with these recipes. So then, beyond that, we also have some additional videos online if you get to look through our playlist of the Code Remix Summit that we have on YouTube, which is the same channel as where you're watching these live streams as well. And then you'll see that we have additional videos from Choice Hotels, as well as one from Chris Jenkins on communicating in types. And beyond that, next week, I won't be here because I'll be in Stockholm. I'll be giving a presentation on trusting AI to modernize software at scale. I did a first one run just yesterday. And then if you're not going to be in Stockholm, but you are going to be in Luxembourg, then you can catch it there as well. And while I'm there, we'll have some colleagues over at the Open Source and Finance Forum in London. So if you're near there and you would want to reach out, that would be the place to do so. So all good things looking ahead. And then, yeah, that's it in terms of updates that we have for this week.
Which brings us to today's guest, Andrew Stakhov, who is our resident .NET expert, Roslyn compiler internals guru, and our bridge out of the JVM ecosystem into other pastures. Maybe they're greener, maybe they're just different colors. It'll be interesting to find out. Andrew, welcome to Code Remix Weekly. How you doing, buddy?
Good. Thanks for having me.
Yeah. So how did you, I opened this up asking Tim about the language ecosystems he's worked in his career. What does like the breakdown of language ecosystem look like throughout your career? Have you been a .NET guy the whole time? Have you kind of gone from one to another?
I think I started foraying into languages with like VB6. And then when I started going to college, they primarily taught us Java, but .NET was just becoming a thing. Like it was literally just getting released. So I was like, do I want to compete with all the guys that have like 20 years of Java under their belt? Or do I want to like start at the same starting line as everyone else? So I kind of chose my .NET path, and it's been good to me. I think, I kind of contracted for a while with like different companies and kind of got a chance to apply, but I pretty much used .NET since version 1.0 beta.
Nice.
So I've been through all of it. .NET is an interesting beast because it kind of gets a little bit of a bad rep, which I think is not true anymore, but it's kind of been earned historically for being a Windows-only technology. And it's been kind of dying on the vine there for a while because, people were moving away from Windows.
Right.
A lot of these other platforms were coming about. So it almost looked like the ecosystem might die. And Microsoft made a quite difficult choice to break backwards compatibility.
And the .NET Framework to .NET Core transition, is that right?
Exactly. So they created this .NET Core, which was cross-compatible, but in the process, they dropped a lot of baggage that was dependent on Windows.
Yeah, I think the last time I used .NET was like right before or maybe towards the beginning of that transition. I want to say that the last time I was developing C#, it was .NET Framework 5. That's that, if my memory serves. Maybe 6. Yeah.
Yeah. Well, if you're doing 5 and 6, that would be like .NET Core. So it's actually fairly recent. You're probably thinking like .NET Framework. .NET Framework is the old Windows one around Core. Yeah. The interesting thing is right now, the .NET Framework, which is the old like legacy Windows only thing, has generally been considered. Microsoft doesn't like to use the word deprecated, but they use it feature complete.
Interesting. That does sound like like a developer was like, how do I tell people this thing is deprecated and we're never going to touch or use it? It's dead. It's completely dead. And a marketer was like, it's complete.
But yeah, basically the new stream was.
You've given me a funny image of like someone at an officiant at a funeral declaring the corpse feature complete.
Anyways, right now we don't have .NET Framework, .NET Core. It's just .NET now. That's what they're calling it. So they dropped all of those differentiators. But yeah, I've been kind of excited to join the OpenRewrite bandwagon with Moderne and build out the C# story.
Yeah, totally. Obviously, all the problems that exist in the Java ecosystem exist in every language ecosystem, as they're broadly just the challenges that come with having a lot of software that you have to manage and patch and update and maintain. So kind of regardless of whether you are writing Python or Java or anything else, these are just challenges that come with the code.
Yeah, absolutely.
Perhaps even more so the moment that you want to drop that backwards compatibility, because that really means that you have to cross over to the next.
I think that was one of the pivotal moments for the ecosystem, because it actually caused a certain degree of renaissance to happen, and the innovation just skyrocketed. Like, we're seeing features being added very, very quickly to the language that makes it like so pleasant to work with. The last few years, they went on this journey to greatly optimize performance, where frankly it is probably one of the most, if not the most, performant type safe language out there, like memory safe language out there. Yeah.
To that point, I remember when I was at Microsoft, they had an internal like big data kind of platform. I was working in Windows, so the angle that they were in, the team around me was interfacing it with was in taking like telemetry that had come back from Windows installations about what features were used, how they were used, is anyone clicking our button, kind of thing. And they had been, there was like this big data pipeline, and teams who wanted to like get out stuff they were interested in could like slot in little programs that would extract, transform, load the information from that data pipeline. And there was a lot of angst about, oh, should we allow C# in addition to C++? We're worried that it won't be performant, and someone's bad data pipeline will slow down everyone else's programs thereafter, because it was kind of this like shared resource. And when they started allowing C#, they found that it was they were faster on average than the C++, extract, transform, load modules that people were snapping in. And they were like, well, maybe hyper optimized C++ could be faster than a typical C#, but typical C# is faster than typical C++, with people who are not writing their own memory management. That was
it's interesting you bring that up, because in the last few years, .NET has actually added a lot of constructs and ways to utilize memory in a very efficient way, like reducing number of allocations. You get something of an equivalent of managed function pointers now, where if you're writing or trying to write highly performant code, there is constructs available to you that many developers generally don't touch. But if you need to squeeze out, C++ level of performance, it's there. And like, seeing the benchmarks, I think they more than tripled the overall performance of the framework in the last few iterations.
That's impressive. Yeah, I watched a really interesting presentation. I want to say it was at a recording from Game Developers Conference, where I think it was Blackbird Studios were talking about one of their homeworld real-time strategy games, which was all C#, and all the coding practices they adopted to make for really predictable frame rates. And high performance game around how they would make sure to allocate as much as possible on the stack, and really be judicious about their usage of the heap. And that was kind of the first time I realized, or I'd heard that C# was giving them that level of control over their memory allocation. So I thought that was a pretty cool thing. So you don't just program in C#. You get it, or rather, when they made that transition from framework to core, is that also when the Roslyn compiler came about? Because that wasn't the original C# compiler. That was one that they kind of came up with later. Isn't that right?
I'm not sure about how the history of Roslyn came to be honest with you. I'm sure a lot of the original bits of the original compiler formed the foundation for Roslyn. But when Roslyn appeared, they started describing it not just as a compiler, but as a compiler as platform, or compiler as a service. With the idea being is that it's not just used to compile your projects; it's used to inform everything you want to do with the code base. In fact, like most IDEs, leverage Roslyn for intelligence to provide you visibility. Like, if you look at JetBrains, which pretty much covers all languages, they tend to build their own syntax and semantic processors for each language, except for .NET. .NET, I think, is the only one where they actually call from Java into Roslyn, because it's just so easy to use and provides such powerful information for .NET processing. And to be frank, it's been optimized the hell out of to be extremely fast, specifically to provide intelligence in scenarios like UI, where you need like snappier responses. Recently, they also started adding some APIs on top of it, which are exposed to developers to do things like build-time code generators. So as a developer, I can, for example, go and add logic that looks at the code that's already I submitted for compilation, and then generate something additional for that, which is super useful. I'll actually show some of that today.
Yeah.
You can write things that find issues inside your code and highlight them inside IDE. And taking it a step further, you can then associate those issues with fix-ups so that you can actually create automatic remediation recipes. And traditionally, these things have been available to you inside IDE. I don't know if a lot of developers actually realize that they're modular. They are distributed as NuGet packages, and you can write them on your own. So a lot of developers feel like those things are
magical.
Well, they probably associate them with IDE feature. It's not. It's actually a .NET feature, and a lot of those analyzers that examine your code for quality actually ships with the .NET SDK out of the box, and for the most part enabled out of the box. And one of the cool things that I've actually done over the last few weeks is take those recipes and bridge them with the OpenRewrite ecosystem, so you can now actually access them directly inside the Moderne platform, or even call them from mod CLI.
Nice.
And be able to execute them. So
yeah,
and you can author your own if you want to, based on
yeah, right on. So is it? Should we do a demo of one now then?
I think so.
Yeah, great. Yeah, go share your screen. Take us through it. Should have a little present button down at the bottom.
Yeah. Share screen. Which one is screen? Can you guys see?
There we go. Yep. Can you make the font size in the IDE a bit bigger?
Damn it.
Wrong zoom.
Let's see if I can just increase. How's that?
That's great. Yeah.
Hopefully that left me enough space to work with. But
yeah. Well, if you need to shrink it again, it should be okay. I moved where our pictures appear relative to the screen to give it a little more horizontal real estate.
Yeah. So one of the things that .NET actually has is the ability to spawn projects based on templates. And again, templates is something that's you can create on your own. But there's actually a Roslyn template that helps you create these things called analyzers. So just from a terminology perspective, an analyzer is something that looks for issues inside your code base. So it basically uses both syntactic or semantic logic to identify issues, and basically almost put like a marker on your code base saying, hey, you have a potential issue here. And the other thing that you have is a code fix-up provider. And a fix-up basically targets specific issues generated by analyzers. So it's almost like a unique constant ID. So they look for those IDs, and then they know how to fix up that particular issue type in that area. And inside IDE, you can actually see a lot of that out of the box, right? So I have a vanilla project here, and you can see like a little squiggly here under 2 stars. So if I point that, you'll see member 2 stars does not access instance data and can be marked static. So it basically says, based on how you're using this method, it can be turned into a static.
Mm-hmm.
This first part is the ID. So this is the diagnostic ID that the analyzer basically created, and the description of that ID is this. If I click this little chevron over here, you can see I have a make static. So this is where a diagnostic also has a code fix-up associated with it. Not every diagnostic will have a fix-up associated. Some are just for informational purposes, but this one does. So I click on it, and boom, it did it. Mm-hmm. You'll also notice I can actually do a bulk refactoring. So, oops. It does allow me to apply it to either file or project or the entire solution I have open. Mm-hmm. Right, and then you have another one here. So let's take a look at what it would take to create one of our own. So I took the liberty of spawning that template and slightly customizing it. So just for the ease of what we're going to be showing today. Mm-hmm. So let's open up this guy and take a look at what this template spawns. So the template spawns 3 projects. We have the analyzer project, we have a sample, and we have tests. So the sample is literally what I was just showing you. It's an example of a code that has that you're going to be trying to invoke your analyzer against.
Right.
The analyzer itself is just a class that inherits from diagnostic analyzer, right? So in this case, we're basically saying we're targeting C# language. You generally have a analyzer per a diagnostic ID. So diagnostic ID is like the issue ID, right?
Yeah.
Mm-hmm. So in this case, you generally override a property called supported diagnostics, which returns an array of diagnostic IDs that a particular not just IDs, like descriptors, like with names and everything that this particular analyzer supports. Because you can actually have more than one. Like it can. Of course. Most cases, it will only deal with one, but you could have more than one per analyzer. There's generally just 2 methods you need to implement, and the template kind of stubs this out for you. So you can enable or disable concurrent execution. The main one is this. This is where you subscribe to kind of callbacks on what's going to happen. Think of it as like a callback for the visit method. This is pretty much the closest equivalent, right? So for every type of operation, whether it's semantic or syntactic, you're going to get a callback. This params is what tells you which callbacks you're registering for. Like you can, there's this giant enum. So you can basically say, I would like to be notified when, we're visiting is null expression or, class.
It's very similar to choosing a visit, a syntax, like overriding a visitor and deciding I want to visit method declarations. I want to visit class declarations.
Yeah. Keep in mind, like in this case, we're subscribing to operations. So there is like other things you can subscribe to. So you can register for like code block. There's different actions, and I'm not going to go into like the whole different model. But the reason that it's structured this way is, again, for performance reasons.
Right.
Because compiler actually takes incrementally tracks which ones have been called, and some of the actions happen only partially. In this way, it guarantees that you're going to get the right callbacks you're interested in without having to invoke a much broader compilation.
Right.
And this is actually the common problem that we've seen in OpenRewrite with other ecosystems, where, if you're trying to build a refactoring engine, most compilers are tailored towards only one goal: compiling the project in its entirety. So if you're trying to look at just a very narrow portion of it, but with extreme speed, their APIs are lacking.
Yeah, one thing I was just thinking that last week or the week before, I was investigating performance issues in some recipes, and some of that was down to a recipe doing multiple traversals of the tree in order to accomplish what it needed to do. And this is a broadly applied recipe that affected many trees, so just the repeated traversals ended up being expensive. And I've been trying to think, is there a way that we could traverse once and apply a bunch of transformations from recipes? As this looks like, by leaving the traversal up to the Roslyn compiler, it can traverse once and just notify everything when it does a relevant, when it does traverses an element of interest to one of its analyzers.
Well, that's exactly it, because a lot of the, especially the analysis phase, can be parallelized insanely, right? Because you're not changing the code. Once you start transforming it, now you have to think about it. It's like, okay,
invalidating caches, got to recompute things. Yeah,
you got to recompute things, because if you're trying to do things in parallel, one guy modified this code, another modifies the same file. And now I have a conflict, right? So there's actually an entire strategies available in this framework for dealing with what's called a bulk fix-ups. So it actually tries to batch things in a way that still creates predictable and correct results without going down the very kind of naive, let's loop through the entire solution and over every file and visit it kind of approach. But as you mentioned, the scanning phase kind of already helps you identify which areas to look at. And in the process, many times you don't even have to look at the semantic portion anymore, because once you've kind of, drew a red box around the problem area, the actual part that deals with, fix-up can infer the surrounding context without asking a compiler for semantic details about that context. There's enough available already. So the callback we're getting, this analyze operation, right? In this case, we're basically saying, okay, we basically want to skip over if it's not an invocation operation, because you may have other ones. We look for a method invocation. So in this case, and then we're basically checking if, this particular analyzer, what does this do? Title. So this particular analyzer checks if the speed of light has been exceeded. So in our particular example, we have a method called set speed, and this particular analyzer is trying to find any invocations of this method where the value is higher than this, because you shouldn't be calling it like that anyways.
Right. You need a special FTL spaceship class to exceed the speed of light, but for any regular spaceship, it should be below that galactic speed limit. Yeah.
Exactly, right. So in this case, here I have a method call to spaceship set speed, and you can see that the 3,000 or whatever this, I don't know how many digits, 300 million is highlighted because that particular analyzer says, hey, it must be lower than the speed of light.
Mm-hmm. And this is, of course, a custom analyzer that you put together that you were showing us the implementation of. We don't, yeah.
Yeah, exactly. So in this case, we're basically checking, okay, is this particular invocation has only one parameter because we know it only has one parameter. Then we grab the first argument, and pretty sure there's a check somewhere for the type. One sec.
I don't see a type check, but I see a
Here.
converting it into a string.
No, it's right here. So this line right here.
Uh-huh.
So this particular method symbol, receiver type name, if it matches spaceship, that's what we're interested in.
Yes, makes sense.
Right. So we and this particular type is actually a semantic check. So even though over here I don't have a full namespace, we can easily add it because the receiver type is actually not just the syntactic portion, the stuff you would see in the class, but it would resolve to a full namespace, and you get all the bells and whistles that you would normally see in a type attestation model in OpenRewrite. Does that make sense?
Mm-hmm.
Because sometimes you have ambiguity and you need to know that information to accurately target it. So in this case, we're basically trying to grab the value of that argument, and then we're checking if it's if it's less than that, we just break out early. But if we get to this point, we're basically saying, okay, you're calling that particular method with a value higher, so we're gonna create a diagnostic. We're gonna attach it to the location of the argument syntax. So the argument is the syntax LST, and then we are gonna give it the message format value.
Mm-hmm.
And then we'll
basically the diagnostic, yeah.
Yeah, and then we're going to report the diagnostic, and that will actually surface it in the UI, but it also influences compilation, right? So if I go and compile this code now, you can see the compiler is actually now issuing me warnings.
Yep. For
those things. So this is not just like pure informational. This is actually baked directly into the compilation pipeline now. Yep. And you can go as far as say that even though this particular diagnostic was created as a warning, I want to treat it as error. So I may actually block compilation entirely if I don't want any warnings in my code base. I personally do that to my code bases because if you have a warning, you either explicitly ignore it on a case-by-case basis, or you go and fix it. You don't leave it in there because it's there for a reason.
Sure.
Yeah, just this morning I was contributing to a different open source project, which indeed also had that same setting. And it is refreshing when you have zero warnings, but it is also challenging when we only jump into something from time to time.
Yeah,
right.
Sure.
And then
so when could we see one of these running as a recipe?
So let's see it running as a recipe. Did we want to look at it in the platform?
Let's look at it in the platform. Yeah, have a nicer UI to share there than the CLI.
So the analyzers are bundled as NuGet packages, and we wrote an adapter to execute them as part of the what do you call it?
An OpenRewrite recipe?
Exactly. An OpenRewrite recipe. So there's a wrapper that lets us import 3 packages that have been floating out there, seeded with a whole bunch of these analyzers and fix-ups. We only took the ones that actually had fix-ups associated with them. Technically, there's over 1,000 analyzers, and we could turn those into like a scanning recipe if we wanted to, or like a search recipe. But for now, these are actually the ones that transform your code.
Yeah, this is very similar to what we did with code mods in the JavaScript TypeScript ecosystem. Wrap them in a recipe so that OpenRewrite users can benefit from many refactoring technologies, not just the ones that we've created originally.
Yeah. So like 95 recipes came from Microsoft, 208 from the Roslinator, and 66 from this Mezianto. I don't know how to pronounce that.
Your guess is as good as mine. So yeah, let's run one of these.
Let's run one of these. So let's see, net analyzers. Let's see if this one is in play. I scoped down to just one repo for the purpose of the demo, so they run fast.
Sure. Click on the repository status tab. We could probably see if it is. Oh, here we go. No results.
Well, okay, so I know, for example, this one appears in this list.
Yeah, you could go from the activity view. You could go back and replay.
Yeah, let's just open an existing one I ran earlier. So here we ran one that looks for generic overload when a type is known. So sometimes you have same method, but one takes a type parameter and the other one takes a generic syntax. And it basically says, hey, if you have this available, then you should probably be using it.
Yeah, that makes sense.
Yeah, so you can see that like this particular recipe executed just great, and then it applied. And we have like a whole bunch of these available now.
Yeah, so we'll just bundle all of these together into a kind of common static analysis issues for C#, and have one of those just like we do for the Java side. Yeah.
Yeah. So and go ahead.
And of course, all the options to then help this standardize across your organization or across a couple of hundred repositories is going to be very helpful.
Absolutely. Interestingly enough, I found that the performance quite fast because all the recipes that we had here, like what is this, like 350? So I ran all of them on the one large repo, which was like, I want to say like 100,000 lines of code, 100,000 files. And that executed in about 15 seconds.
Wow.
All the recipes.
Is that demoable now? Like, is that in a working state at the moment?
Well, not on SaaS, but I can do it on a local if you want to see it.
I'd be more interested to see it running on the SaaS.
Maybe next time we do this, I'll show it.
Next time we can provide an update showing a composite of many of these running together. Any other analyzers or fixers to show off? So I guess you showed us the implementation of an analyzer, and then we saw one of the recipes, or we saw it running in the SaaS, making some suggestions. What does the implementation of a fix look like?
So let's take a look at the fix. So the fix actually looks like this. So you inherit from a code fix provider. You target some analyzer ID, right? So I basically say I want to register a code fix. At this point, you're here. So you override the fixable diagnostic IDs, and this basically lets you notify the compiler saying it's like, hey, anytime any analyzers produce those IDs, I might be interested because I can actually deal with those. And then the compiler will basically give you the callback saying, okay, these are all the instances of that particular diagnostics where it appears. And at this point, you're manipulating syntax tree, right? So I can take the diagnostic, find the source span. So this is like a portion in the text offset where it belongs. And there's syntax. There's API available for you to find nodes. So you basically can convert a text position within a file into a corresponding node inside the AST tree, right? So in a language tree, we basically find the node under which that highlight happened. We know that those node is generally should be a class declaration syntax. By the way, this code fixer is for different issues. So this one deals with anywhere where a class name has a my company in its name, right? So if you have a like this, right? So if you have a class declaration has a particular string, then it has this. So in this particular case, we're saying, okay, if it's not class declaration, bug out early, but if it is, we register a code action. So instead of actually applying it, we're registering an action that will be performed at that particular site. So when you invoke it, it's almost, think about it as like a collection of delegates, because a particular fix might actually involve fix in multiple portions of a file and potentially other files. Like you might think about a rename operation, right? Like you're renaming both the declaration and then anywhere
sites, yeah.
Yeah. So in this case, you're registering code actions that will go and fix it up across the board, right? And then the actual thing that does it is here, right? So this is the sanitized company name, right? So you get a document, you get the class that we extracted, and this is the thing that actually does and performs the transformation in that particular context. So it's a little multi-staged. So and kind of like, instead of implying that you're going to be doing both searching and then transforming and applying, it's almost like split up into 3 distinct stages, and you're in control which stage you're invoking. The advantage of it is because things are more or less kind of identified and scheduled, it lets you come up with an optimal strategy to apply them in bulk. So there's actually an optional override you can implement that informs it how a particular code fix-up can be applied in bulk across the entire project. So you kind of batch them up. There's a default implementation of that available that you can go and execute, but it's, in my experience, seems to work quite well out of the box. You'll notice that Roslyn actually gives you a lot of very powerful refactoring tools out of the box. Like, for example, a renamer can target an entire solution and take a semantic symbol. So in this case, in this case, we're basically saying we want to rename a class, but that also means finding all the instances where that class is used and adjusting them, right? Normally, this is a fairly elaborate recipe that you would have to write, but with the renamer, it turns into a single method call, right? And the end result is basically a new transformed solution.
All right, that makes sense. So what else can we see in the way of demos?
Well, this probably all looks quite cool, but a little bit alien to you. And if I told you it's like, hey, Sam, go write me a recipe, or like, okay, give me a break. I'm not doing that right now. Interestingly enough, because Roslyn has been around for so long and so many things have been written, the AI engines are actually very versed at creating recipes for you just by asking them to do it. So let's see if we can do that right now. We're just going to use ChatGPT to give us a new recipe and see how far we can get. So I have a method here called setSpeedAsync. I know Java doesn't have async await, but hopefully you're familiar enough with other languages to know the paradigm.
Yeah.
And it's generally preferred to use the async version if it's available to you. So the idea is like if you're already inside an async method and you're trying to call another method, you should prefer to call an async versus async. So over here, I have
an asynchronous method that is calling the synchronous set speed, and so it's not being able to take advantage of the concurrency that the runtime provides.
Yep. So let's see if we can write an analyzer. I think this is like a default one that's actually doing it right now. But let's see if we can create one that finds this set speed method, and then if we're inside an async method, transforms it into this. So this is essentially the recipe that I wanted to do. I think this is actually a fairly common scenario for like a lot of the transformers that we write. So let's go and ask ChatGPT what it thinks about this. So write me a Roslyn analyzer that targets any invocation to method public void set speeds. On class, we give it a full class name. If such invocation is done inside async method, then the invocation should be changed to async version of this call. I'm also giving it some hints on how to structure the analyzer. Also, well, that's fine. Let's just leave it at that.
So far, so good. This is looking pretty similar to the code you showed us for the handwritten analyzer.
Yeah, I'm not gonna go and read this too much. Let's figure out if it works out of the box. We're gonna do some vibe coding here. So what is this one called? Set speed analyzer. Copy this guy here. Okay, no compile errors on this one. And it also gave us a fix-up. So let's create a fix-up. Oh, I forgot an import somewhere. Let's see if it can fix it for us. see. Okay, no compile issue there. Let's build it and see if it works. So we go to our sample and
if this works, you're gonna be very rapidly one of the most productive recipe authors I think we have on the country. As long as you have tokens to spend on this solution.
Yeah, exactly.
there you go. So there's the analyzer firing. So it highlighted the whole method call. You can see
the
that
ID is my001 as opposed to the similar Microsoft provided analyzer. Yeah.
And let's look at the use set speed async. Bam.
Oh.
There you go. Yeah. Basic transformation recipe in just a minute. Yeah, totally vibe coded. Yeah. That's pretty cool.
So let's take it a step further. So, okay, we wrote this in C#. Now we want to turn this into a mod recipe, like something OpenRewrite recipe. So I have a template project created over here. And we have a base class called Roslyn Recipe that essentially takes information we need to invoke this recipe and shells out to .NET process to do the actual work. The actual recipe just needs this. So you need the diagnostic ID we saw, the NuGet package where it lives, and the version, and obviously the descriptions. Now, we already have this information in .NET. I don't want to actually go and duplicate it. So I have this little build task over here called generate me Java recipes. So this will go and find all the recipes inside my analyzer and generates a code stubs for me on the Java side. So we're just going to run this guy, switch here, and you can see I now have this folder, my analyzer. So I had two analyzers. There's our MD001, and it copied everything from the .NET side.
Nice.
Cool.
Yeah. Cool.
Now, shall we? Let's see if it works. Right. So we have a test harness available here.
Yeah, and this is the same rewrite test everyone's used to, just laying out a .NET project with some .NET sources just listed as text files.
So over here, I basically have the before. We have the ship set speed. We're expecting it to transform into this. And the recipe is going to be a little different now. So what did we call this one? This is the one we just created, right?
Oh, it probably needs to import it because it's the package is different. There you go.
Well, I need to put it on NuGet. Actually, I was rushing. It may actually work. Let's see if it will work. I did something that may actually get this to work, but let's find out.
Let's try it. See what happens. If it doesn't work, that just shows the degree to which it's a live demo.
So I basically don't want it to go from NuGet repository because I don't want to go and publish it. I just want it to restore from a local one.
Okay.
So I have it pointing at the feed.
I see. So kind of like the Maven local equivalent kind of thing of where
it's exactly it. I'm just going to go and clear out my cache because I don't want it to try to use an old version from cache.
So we need to go rebuild your analyzer to repopulate that cache, or?
Yeah. So right now I'm gonna. So what I'm gonna do is run another target called pack, and what this should do is create an artifact in the artifacts folder. So there's the NuGet package, right? This is the equivalent of your jar file.
Yeah.
Now, in the .NET world, you can point to a feed as either a remote URL or an actual folder on your drive. So in this case, I'm actually swapping out NuGet.org, which is where most packages are published, for just a folder on my drive.
Right.
And let's see if it will work now.
Thanks for the kind words to Sean. Appreciate you stopping by to say hi. Yeah, I agree. You're awesome too. What error was that?
I don't think it ran. It was too quick for Gradle. Oh, there we go.
So we didn't get a change. Description should not be null or empty. Yeah, that's probably from our test framework trying to help you with. Yeah, go put a period in there. It's a sentence that needs to end with a period. There you go. Yep. Now run it. It'll be fine.
Sometimes you need very strict guidelines on your documentation, such that it all works well.
Oh, look at that! The test passed.
Yeah. Yeah. And it didn't. And most of the time was just the Gradle startup time. Yeah, I could tell that it ran quickly. Yeah. That's really cool.
Yeah.
Yeah, so in this way, we can bootstrap a C# recipe ecosystem with all of the existing .NET analyzers, and then when it comes to writing migrations or anything else that you might want a recipe for in that ecosystem, can leverage all of the existing powers of the Roslyn compiler and all of the existing tooling. Which I think highlights a very pragmatic approach we have to doing this refactoring, where just because it's like in the Java ecosystem, when we saw refaster templates were a thing, we found a way to run those as recipes, and then when we saw that code mods were a thing in JavaScript, TypeScript, we found a way to run those as recipes to just kind of create a unified wrapper that can run any kind of transformation or update that you might want to apply to your code base, whether it's one based upon an OpenRewrite LST or any other paradigm. We'll take it all, assimilate it Borg-like into a software refactoring utopia. Yeah.
Yeah, I think the fact that you can generate a lot of these recipes with AI and very accurately because it's so familiar with that particular code space. It just has a lot of training data available to it. In my experience, it pretty much nailed everything either on the first try or just with a few minor fixes. So you can stamp out these recipes like so rapidly, in my opinion, with this approach, just like you saw me do right now.
Totally. We're kind of coming up on a full hour. Are there any last demos to get in before we kind of go for closing remarks?
No, that's pretty much all I wanted to show you guys.
Yeah, that's pretty sweet. So I guess one kind of question I have as a C# outsider, what are the kind of like burning needs in that ecosystem? What are the things that if we created recipes for them, .NET developers or .NET development shops would be really excited?
There's a number of packages that have changed their licensing model in the last few years.
Tech stack liquidity, yeah.
Yeah, and there's a lot of companies that are quite pissed about that and trying to switch to an alternative.
Yep.
Yeah, so I think that's going to be the sweet spot for this. Migrations between .NET versions, I think, are probably best handled by the .NET upgrade assistant, which we already wrapped. It's already available on the platform.
Right.
And I'll be like pragmatically honest with you. It doesn't do a perfect job, but a lot of things, as I mentioned at the beginning of the call, have been dropped. Like certain paradigms just don't exist in the new versions that can be easily adopted. So they're so different in the approach that it's impossible to do that in an automated kind of way. It's more like a complete rewrite at that point, right? Like we're talking, for example, like event-based web rendering model switching to an MVC type or
Yeah, if there's type 1 to 1, then yeah, you have a hard time automating that as well.
For sure.
Absolutely. So I think people need to be understanding that there's limitations of what you can realistically upgrade to.
Of course.
But so I think Microsoft themselves handle the upgrades from version to version pretty well with that tool. But upgrades between versions of libraries, and especially, like I said, the ones that have gone commercial, might be the sweet spot for us now.
Yeah. Well, very cool stuff, Andrew. Oh, go ahead, Tim. Sorry.
That's the exact point where you're not going to get any vendor support, I imagine. So then having
For sure.
a way for the community to move to something else is should be interesting.
For sure. Well, really exciting stuff. Glad to see our recipe infrastructure in this ecosystem bootstrap to hundreds of recipes so quickly. I look forward to maybe next week or very soon being able to put out a video clip showing the results of running those several hundred fixes on a set of real repositories. It was great to see one running in the SaaS. It'd be even cooler to see one. It was cool to see one fix analyzer and fixer running as a recipe on one repository in the SaaS. I look forward to seeing several hundred running on several hundred repositories and getting that that kind of wow factor of seeing that refactoring at scale. And then it'll just be a matter of talking to our clients, customers, community, figuring out what the .NET needs are. And we'll go from there. So thanks so much for putting this together, Andrew, and thanks for joining us.
Thank you, guys.
And thanks everyone who watched this edition of Code Remix Weekly. We'll be back next week with the topic that I haven't figured out yet, but I'm sure it'll be good.
Okay. Looking forward to it. So thanks all, and see you next week.
Thanks all. Bye.